So we are given these 5 molecules and are asked to determine how many of these molecules are polar. So we're going to start out with BeCl, which is BeCl2, which is beryllium chloride. Beryllium chloride has 1 beryllium atom and 2 chlorines. Now, when we create our Lewis structure, we need to remember to place the atom with the highest electronegativity towards the outside. And if we look at our electronegativity chart, we'll see that beryllium's electronegativity is 1.5, while chlorine's is 3.0, meaning that beryllium is going to be the more electronegative atom. So, as I've already done, we will put chlorine on the outside and beryllium as our center atom in our molecule, in our Lewis structure. Next, we need to determine the amount of electrons that will go into the Lewis structure. So we know that chlorine has 7 valence electrons. We're going to times that by 2 because there are 2 chlorines in the molecule. And we're going to add the 2 valence electrons from beryllium, and that's going to give us 16 electrons that we will put into our Lewis structure. Now we must try to give all the atoms octets, starting with the outside atoms. So we're going to add, first we're going to put our shared electrons. We have to remember that each of these are 2 electrons. Keeping that in mind, we have already used 4, so 16 minus 4 is 12. So we have 12 electrons left to put into our Lewis structure. We're going to put those 12 on the chlorines to try to form octets. And as you can see, the 2 chlorines both have octets, but the beryllium only has 4 electrons. Now, this is going to be a common mistake, as most people are going to think, oh no, the beryllium only has 4 electrons, it needs 8. Why don't we take these and share them with it? But that is wrong. Beryllium is one of the atoms that's perfectly fine having less than 8 electrons. So the proper Lewis structure is actually going to look like this. And yes, the beryllium is not going to have 8 electrons. But next, we're going to place the bond dipoles. The highest electronegative atom, which in this case is chlorine, will have a partial negative charge as the electrons are going to drift toward the atom with the highest electronegativity. So there is going to be a partial positive charge on the beryllium atom. The bond dipoles will have a positive tail on beryllium and a negative head at the Cl, the chlorine. The bond dipole arrow shows the direction of the charge separation, positive going to the negative. The charge separation is going in these directions. The arrow's length represents the magnitude of the charge separation. So, thinking about the molecular geometry of this molecule, we see there are 2 domains on the beryllium atom, meaning this molecule is linear. So we have 2 bond dipoles, each reading in complete opposite directions, positive tail at beryllium, negative heads at each of the chlorines. These bond dipoles are going to cancel each other out, meaning there will be no net dipole, which will make this molecule non-polar. Next, we have SO3. So, I've already done the Lewis structure for this one. We're going to have, of course, 3 oxygens and 1 sulfur. And they're going to be joined together by a total of 2, 4, 6, 8, 10, 12. 12 shared electrons, which are 6 bonds. Now, this is another common mistake, as people will think, oh no, 6 bonds to 1 sulfur, that's too much. We must have did something wrong. But actually, sulfur, if you look at the periodic table, which is, this is still the periodic table, it just has the electronegativities, you'll see sulfur is below the 3rd row. It's actually on the 3rd row of the periodic table, which means it can have more than 8 electrons. So this is the correct Lewis structure. And on this we see the sulfur has 3 identical domains. And in this one, the bond dipoles with the positive tail at the sulfur and the negative head at the most electronegative atom, which in this case are the oxygens, are going to cancel out, making this molecule as well nonpolar. So here we have OF2. Now we have 20 electrons, 6 for the oxygen, and 7 times 2 for the fluorine. And this is what our Lewis structure is going to look like. As you can see, everything has an octet normally. But now you might look at this and say, oh, that's linear, because it has the oxygen, the center atom, has 2 domains. That is a common mistake people will make. But in fact, if you draw the molecular geometry out, you'll see that it is in fact bent, as it has 2 lone pairs. This will create a net dipole, which will make the atom polar, the molecule polar. Next we have CCl4. 4 plus 7 times 4, 4 for the carbon, 7 times 4 for the 4 chlorines is going to equal 32 electrons. And this is the Lewis structure with the partial charges. And the purple arrows are the bond dipoles, positive tail at the carbon, negative head at the chlorine. And here you see the carbon has 4 domains that all the bond dipoles cancel each other out, making this one non-polar. And finally we have the ozone, O3, 6 times 3, 6 valence for each oxygen, and there's 3 oxygens. It's going to equal 18 electrons. This is what the Lewis structure will end up looking like. And now you might look at this and say, okay, 2 domains, forgetting that there is a lone pair right here. And once you draw it out, it's going to look like this. You can see that it is indeed bent. So this is also a polar molecule. And you can see that it is polar.